Hello, calculus fans. Let's talk about functions of three variables. So a function of three variables is a rule that assigns each ordered triple in some domain, that's in R3, some unique real number that we're going to call f of x, y, z. So as an example, we could say that the temperature T at any point inside a warehouse depends on the coordinates of the point in the warehouse. Maybe if that point is closer to an air conditioning unit, the temperature will be lower. All right, as an example of a function of three variables, let's find the domain of this function, g of x, y, z equals 1 over 4 minus x squared minus y squared minus z squared. And let's describe the level surfaces. So the domain is the set of all x, y, z that makes the denominator non-zero. Right? When you have a fraction, the denominator cannot be zero. So let's write down what the domain is now. It's the set of all points where 4 minus x squared minus y squared minus z squared is not equal to 0. And that's the same thing as saying x squared plus y squared plus z squared is not equal to 4. Here's one way of thinking about this. The domain is the set of all points that are not on the surface x squared plus y squared plus z squared equals 4. And we recognize that surface. That's a sphere of radius 2 centered at the origin. Notice that the question asked for level surfaces and not for level curves. You see, the function is a function of three variables, and so the domain is three-dimensional rather than two-dimensional. So a level surface of a function of three variables is a surface of the form f of x, y, z equals to some number k. K is a constant in the range of f. Now, in the case that we're dealing with here, let's look at what the level surfaces are. We'll look at them algebraically. We take the function and set it equal to k, do a little bit of algebraic manipulations, and we end up with x squared plus y squared plus z squared equals 4 minus 1 over k. This is a sphere of radius square root of 4 minus 1 over k centered at the origin. Okay, that's all for now.